Okay. Okay, hey everyone. We are going to start for the CNCF project tours. Welcome everyone to the CNCF project tour. We have Jonah here as a Jaeger maintainer. He will be sharing his experience with Jaeger and how he's doing as a maintainer at Jaeger. Also shares few demos with Jaeger, and we will have lots of fun during this whole session. So also along with me, I'm having Tavmeet and Sandeep. Tavmeet is a senior software engineer at SUSE, and Sandeep is also a senior software engineer at Gen. So before starting, let's have a quick introduction about Jonah. So Jonah, over to you.
Oh yeah, sure, no problem. So my name's Jonah Kowall. Thanks for having me on and arranging the webinar today and the meetup. My day job is that I'm the SVP of Product at Paessler, and Paessler is a German company that builds monitoring software. So we do a lot of infrastructure and network monitoring, headquartered in Nuremberg, Germany. I am based in the US and Florida. That's why there are palm trees, because in Germany it's quite cold. But I do spend a lot of time in Europe. And then in open source areas, I'm a CNCF Ambassador. I'm one of the maintainers of Jaeger, which we'll be talking about today. And I also work on OpenSearch, which is a Linux Foundation project that I helped get started and have been part of the transition into the Linux Foundation for that important project. So yeah, I'm excited to chat with Jaeger and get into some details here. Did you have any other questions? The only other thing I guess we should mention is that if you do have questions during the few slides that I show or the demos, feel free to drop them in the chat and I'll address them as we go. Any other comments, or should I get started with a little background?
Yeah, I think also a few contents for the attendees. We will start Q&A once Jonah started with the presentation. So if you have questions in between, you can just drop your questions in the Q&A section. Also, you can introduce yourself in the chat section, so you can people will know about you and you will know about the other people's other attendees. So yep. We can start. All right.
All right, sounds good. I'm just going to share my screen. I'm going to use a few slides from the most recent KubeCon. So this was in Salt Lake City. And I will kind of get into a little bit of background. Jaeger, just to give you a little bit of context, which I don't have in this presentation, is that Jaeger is part of an observability strategy. So observability is a set of tools that people use for basically use cases around understanding system behavior. So one of the main use cases for observability is monitoring, but there's a lot of other things that you can do with observability tools. It's really designed to help you answer questions that are often difficult to answer. So when someone comes to you as an engineer and asks you, how many of our users that are experiencing errors are in this specific part of the world or have this specific attribute, observability tools help you really correlate the business information with the technical information. And obviously monitoring is one of the use cases, but the other main use case is troubleshooting, which I'm going to get into in detail here. So in observability tools, we tend to have three main signals. The first one that every developer uses when they start programming is logging, because we start to write logs to understand what our systems are doing. The second one that we look at is metrics. So this is measurements, time series data. And the third one is tracing, which is what I'm primarily going to be talking about here. However, I will be speaking also about metrics. So you'll see that in the demos and in the discussion. And the reason why tracing is the hardest signal to use, but also the most valuable, is because it is a very structured type of data. And so what does that mean? Is that it really helps you deal with the biggest problem that any of us deal with when building microservices, which is that you don't know whose problem or whose code is causing a problem when there's an issue. So you end up either bringing everyone together to discuss, will you look at your system? I'll look at mine. You look at your service. Let's figure out where the problem is. Or you end up finger pointing, which is the worst thing for your culture, because you say, it's a database problem, it's a load balancer problem, it's this other service problem. And so tracing helps you really get a solid set of data to understand where the problems are happening. So when things break or they're slow, you know where to go. And hopefully you know who owns that part of the system. This is always the challenge with microservices. So some of the use cases that tracing helps you solve is root cause analysis, like I said, isolating where the problem is, understanding the map of the system. So looking at the right-hand side, these are all Jaeger screenshots, which I'll kind of show you more in the demo, but give me a map of how my services communicate with each other and where the dependencies are. So when I'm upgrading a service, maybe migrating a service to a new data center or a new cloud provider, I know the potential impacts. And then finally, it lets you really drill deeper down into the specific user actions, what's happening in the application. And that in turn helps you collaborate better with other teams. And you can also use this data for monitoring, which I'll show you, and understanding service levels, which is obviously really important for anyone running applications. So a few fundamental pieces of what you need to trace. The first is what we call instrumentation. So this is how do I collect the data from the code or the software that's running? Where do I store that data once I've collected it? And these are kind of the main steps. I'll explain how Jaeger does these things in a moment, but these are kind of generic. Anytime you look at a tracing system, you have to think about these different components or these different pieces that go into making the data usable. So just to explain a few fundamental pieces of tracing, in tracing, the instrumentation that we use is called OpenTelemetry. This is a CNCF project. I believe I heard recently that now OpenTelemetry is the busiest CNCF project, even now above Kubernetes. So it's a very vibrant community, a lot of contributions, a lot of building, a lot of new things going into OpenTelemetry. And OpenTelemetry is designed to deal with all three of these signals that I mentioned: logs, metrics, traces. There's also new signals that we're working on in OpenTelemetry. I won't get into it now because that's different topics and things that are coming up in the future. But when we look at tracing, there's a few key words that I'm going to be using when I show you the demo and we get into the details. The first is a trace. A trace is an end-to-end view or an end-to-end set of data about a request that's coming from a user or an API or something like that. It shows you the complete end-to-end from where it comes into the system, communicating with multiple microservices and other systems until it completes its transaction. The span is a piece of that. So one service talking to another, that would be called a span. So it's one single communication between components. And inside the span, we have things called tags, which are basically attributes that help us understand relevancy for that particular span. So for example, in a span, you'll see all the attributes. Some of them may show me what Kubernetes pod it runs on, what server it runs on, maybe what data center it's in, or what region of a cloud provider. There's a lot of additional information contained in the tags. These are kind of just views of how you can look at traces, because in the trace, there are relationships. And in these relationships, they can get quite complex. So on the left-hand side here, you see that this span, although it starts in one request, it fans out. And we have lots of simultaneous requests happening. So we can look at it like a tree, as it shows on the left. But we can also visualize that on the right-hand side on a timeline. So as time goes, what are all the requests that are occurring over time? So you'll see both of these views in Jaeger, but this is generally how you visualize traces. So I'm going to jump from my slide deck, which I said was part of my KubeCon, or our typical KubeCon talks that we do. So if you do attend a KubeCon, we're going to be presenting in the London KubeCon coming up in early April is the next one that we're speaking in. So I have a demo fired up here. I'm going to just show you a little bit. So Jaeger, just to give you a little bit of history, I'll zoom my browser in. So Jaeger was created by Uber, and it was created because Uber was one of the early companies to adopt microservices. And they had a lot of problems with the current tools dealing with the scale of the microservices they were using. So Uber decided to build their own tool to deal with this. This is how Jaeger was created. The creator of Jaeger, Yuri, he's still a maintainer, and he is, the main leader of the project. He's also a maintainer of OpenTelemetry. He's written multiple books on tracing, and he's very well connected in the community. And Yuri was the creator of Jaeger when he was at Uber. He's currently at Meta. And so he's an engineer there. So to give you an idea, we're going to have an example application where there's a bunch of microservices that are happening, but the idea is that when I want to order a car, I'm going to click on a button. So it's going to show that a car was dispatched, and this is how long the request took. Obviously, when you're running an application, you have a lot of these requests happening at the same time. So I'm going to just run a bunch of these requests so that we have a bunch of data that's now stored in Jaeger, and then we're going to take a look at it. So you can see some of these are starting to be a little bit slow, 2 seconds, 3 seconds to execute. This is kind of the front end for our application. Now, as an engineer or an SRE or an operations person, I then jump into Jaeger. And this is the UI for Jaeger. So what Jaeger does is it first presents you with a way to be able to search for specific data that you want to analyze. So what I'm going to do is I can pick the services that I want to focus on. In this case, all of the requests come through the front end, and then they're routed through that service. So it's sort of like the router of the kind of front end requests. I can look at specific URIs or paths. I can use any type of tags. I'll show you the tags in a moment. And then you could do filtering, like some examples here show, I want to look at errors. I want to look at certain HTTP status codes. Maybe I want to look at a certain Kubernetes pod, for example. How much time I want to look back. Maybe I only want to look at traces that are of a certain performance level. So like 1 second or longer. And then you can limit the requests. I'll just put it at 200. And then I just run the search here, and we have too much data. I'm going to look back like 15 minutes so that it's fine. So these are all the clicks that I was doing. You could see all the transactions. Some of them down here were pretty fast. Some of these are slow. what this graph is showing you is that out of all these traces, some of them are taking close to 2 seconds. Some are pretty fast, 500 milliseconds. But I'm just going to pick one of these and we can drill into it. I can also look at the view down here, which shows basically how many spans are in these individual traces that I was clicking on. And I also can see that there were some errors in some of these. So we're going to drill down into the errors and kind of some of the issues. Some of these are really fast, 30 microseconds. Some are a little slower, 700. It's not terrible, but it's not great. But anyways, if I click on one of these, now I'm seeing the timeline view of all of the different things that were occurring within this transaction, within this trace. So what I see here over time, as the time goes, I can see that there's a bunch of different spans that are within the trace here. There is a database call. There's a bunch of different calls to Redis. The one thing that I want to look for is obviously the errors stick out, this big error button. So I can see that there's an issue here. When I drill into any of these particular spans, here are the tags I was talking about. If I expand the tags, I can do searches and filtering by any of this. This was a Redis request. It's a client requesting data from a Redis server. I can look deeper into the process where it was running. In this case, it's just on my system, so there's no Kubernetes or anything. It's just running in a Docker container. And then any associated logs. So in here, although we know there's an error, I can actually see that there was an exception generated, which is a Redis timeout. So likely the next request doesn't have an error, but this was probably a retry of the same request that was made up here that timed out, basically. The other thing to note, when you see certain patterns in a trace, they connotate bad software practices. So in this case, you'll notice that there's a black line. This is what we call a critical path. So if I want to make this transaction faster, the only things that I need to do as an engineer are speed up the things that have a black line, because everything else is not waiting on that. So in this case, what I see in this pattern, these all have black lines. This staircase view means that this is not being done asynchronously. So these are been doing one after another, after another, after another, these requests, which is not efficient. If I thread these together, I could speed up the transaction by making this, these happen in a line instead of one after another, basically. So that's one thing that I notice here. The other thing is there's this database call, which is relatively slow. I can drill into this. So as I dig into the SQL statement, I can not only see, exactly where it went, what the SQL query was, obviously it's still running on my Linux system in Docker, and then the associated logs. So in this case, there was a lock that happened, and the lock was acquired, basically. So this was relatively fast, but there's still some locking issues going on here because it's showing that the lock was acquired. So that's an example where we should look at the database. We should understand why there's locking going on. Maybe there's other transactions that are making this query wait for something else to finish. So that's not ideal. So those are kind of some of the issues that I would see when I was troubleshooting this. So that is kind of how you would use traces to troubleshoot. I also mentioned the topology view. So in this case, all of those requests that I made, this shows the overall view of the application. So things come into the front end, and then they go down to either of these services. They're either using a driver to make requests to Redis, they're using a customer service, which then is calling a database, MySQL. And this is basically doing the routing between different services. I can also see the wait. So every time there's a request coming here, there's a lot of requests to Redis. There's also a lot of routing requests. So it gives you an idea of the weight of the different parts of the application and the topology. If you have a complicated application, this can obviously get much bigger, the view here. There's a bunch of other really cool features in Jaeger. I'll just talk about a couple of them. So aside from this timeline view, we also have a graph view. So this gives you kind of like the topology of those requests that we were just looking at for that trace. The other one that's really cool is the flame graph. So this will actually roll up the data and make it easier for us to analyze things in a different view, especially in complicated transactions. And there's, this is interactive where you can kind of, go into more detail. And then we have kind of a table view of the same data. You can also see the JSON for the request. So you can actually download this JSON. This is basically what the trace looks like. And that can actually be loaded into the UI. So some people will download a trace, load it into the UI, which we support, kind of file upload right here to be able to visualize JSON that you're getting from other systems, for example. We can also do comparisons. So if we think that these should be the same, I can see the spans don't match up. I can actually pick both of them and do a comparison. And it'll actually show me that the differences are right down here, where some are using this Redis manual get driver and some are not. So it gives you a way to compare and visualize different traces with each other. I'll talk about the monitor tab in a minute because that's a different use case and I have a different demo for that one. But those are some of the features. There's more than that, but that's kind of the basics of what Jaeger does. So I'm just going to switch my demos to one that's more, and these are all part of our repo. So you can see this is just in our public repository. All of these examples I'm running are just Docker. This one's a monitoring example. So we're going to have to let this run for a minute or two to collect data. I'm going to take a look at the questions to see if anyone had anything in particular. Sure.
So, Jonah, for this troubleshooting demo, so you are using any web application or in the background?
Yeah, this is the web application, was the hot rod. And then inside there's a bunch of services calling each other. So that's the example application that we're using for that demo. For the monitoring demo, we're actually simulating the transactions, and it's a different architecture, which I'll show you. We should start having some data. Okay. So let me take a look here because it's a different, now we're starting to get some data from what I was just running. I'll let this run for a couple more minutes. The other thing to keep in mind with Jaeger, I'm just going to flip to my slides because I wanted to talk about the deployment architecture a little bit while that's running. So just to explain how Jaeger works, the components involved here. You have your application using OpenTelemetry. Now with OpenTelemetry, you can either do a automatic instrumentation. There are many languages supported that do auto instrumentation, so you don't need to change your code or do anything like that. If you do want to collect deeper data from your code, there are SDKs for most languages where you can define your own metrics and define your own logs and traces. So OpenTelemetry is another big project you can talk about and definitely can have its own session specifically. I see all the questions coming in, so I'll take a look. To answer the first one, OpenTelemetry does the correlation. So because OpenTelemetry has standards, it automatically will correlate between logs, metrics, and traces for you. With metrics, it's a little bit tricky unless you have certain types of tagging, because most metrics are just based on time. but logs and traces will be correlated if you use OpenTelemetry. Just looking at a couple of the other questions. So the next one I was going to address is the data storage. So after the data comes into Jaeger, we basically have a binary here that acts as a collector. It's compatible with OpenTelemetry. It's actually built on the same code base. And then it goes into storage. Now, the storage for Jaeger is officially Cassandra, Elasticsearch, OpenSearch are the official ones. But we have lots of unofficial support. We're working on adding ClickHouse as one of our supported backends. We test these, they're part of our pipeline. We make sure that it's working with those. But there's lots of unofficial ones. There's many, many. We have a big issue that covers probably 20 or 30 different data stores, and that's where the data is stored. Now, what I'm showing you in the Jaeger UI is this on the right, which is a UI that basically queries the database. The Spark jobs, I won't get into that, but it basically does some data collection. So I know there's more questions. Let me jump into the second demo, and then I'll try to answer more of those. So now that we've had this simulation running for a little bit longer, similar kind of view, we can drill into and look at the different components that are part of this application that's being used. I'm more interested in showing you the monitoring tab. So the other thing that we can do with traces is we can get the metrics from the traces and use them differently. So we built something inside Jaeger where we're you can automatically get these metrics without doing anything. So in this case, we're looking at what we call the red metrics. So red stands for request rate, how many requests per second we're getting. The error rate, the percentage of transactions which have errors, and then the latency, or the how long it takes for things to process. And so we automatically are creating these through Jaeger, and they get stored in Prometheus. To give you an idea, I'm just running the query. So OpenTelemetry and Jaeger are automatically generating all of these different types of metrics that basically are looking at those different sets of data across each service. So you can see that there are many, many different metrics being generated for us. We can visualize these in Prometheus. We can visualize these in tools like Grafana. And we can visualize these in Jaeger. So it gives you an idea of, this is more of a monitoring use case. What's going on with my service? How is this happening? How is this working? So I just wanted to show you the monitoring piece that's part of it. So let's see. So I'm going to answer a couple of other questions because there's quite a few in here. So Darmit was asking, I think I answered a couple of them on instrumentation, but so you can use auto instrumentation, you can use manual instrumentation. There's a pretty big collection of different ways to do instrumentation you can find in the OpenTelemetry docs. Actually, the ecosystem is probably a little bit better. So there's a registry. So if I were, let's say, programming in Go or Golang, I think it might be under, language right here. I can basically pick the different languages that I'm using, and it'll show me kind of all of the different ways that you can do instrumentation and data collection. I'm actually looking, sorry, let me find something a little bit better. So language APIs and SDK, Go. So for example, this shows you how to do the manual instrumentation, but there's also automatic instrumentation options for many of the languages out there. So it kind of shows you, in this case on Java, you can do zero code. These are all basically automatic instrumentation. You can use libraries, you can do native instrumentation. I mean, there's lots of ways to do this in OpenTelemetry. So there's lots of options. And to answer the last question there, Jaeger does not need Kubernetes. I'm running it right now on my machine in Docker. You can run it as just a straight binary. You can run it in Kubernetes. We obviously provide Helm charts and we provide an operator for Jaeger. So if you do want to run it in Kubernetes, we can make it easy for you to do so. We are always, you know, we have good documentation that kind of describes all of the things I was talking about. And we are always looking for help and contributors. You can pop onto the Jaeger channel on the CNCF Slack. That's usually the easiest way. And we obviously have a very active GitHub repo that, you know, that you can participate in. So we're always looking for help, looking for ideas. So sorry to be a little bit over time, but yeah, if there's any other questions or anything else, I'm happy to answer those.
There is one question from Hardik. He's saying, how does tool use in micro front-end flow?
Let me look at that one. How is this tool used in micro front-end flow? I'm not actually familiar with that term. Do any of you know what that means, micro front-end flow? I'm not sure. Yeah, I'm not micro front ends. Oh, so this seems more like just microservices, but it should be totally fine. Like I said, when those application components call each other, you'll be able to see them. So in this case, just in the demo that I had running, you can see that, you know, there's basically subcomponents here. There's, you know, that are running essentially, that are calling each other. No matter how many different calls you have, it'll visualize them. You just have to do the right instrumentation. So it shouldn't be an issue with any kind of architecture. Sometimes these traces can get very long, a lot of spans. Sometimes people have thousands of spans, so it can get a bit difficult to do the analysis, and you have to use some filtering and other things to really get into that. So, but if there's anything I didn't answer, that's fine. And Sandeep, yes, you can collect JMX metrics, but that's more of a Prometheus thing. They have a JMX exporter. You can also do it with OpenTelemetry, of course. So JMX is still supported and around, of course, in the Java world. But yeah, cool. Any other questions or anything like that?
So I have one question. Like, do you know you can share like similar tools, like or similar open source projects in observability
Yeah.
plane, like Jaeger?
So in the CNCF, there's nothing else that does trace visualization, really. I mean, there's other projects in different ecosystems, but none of them are as popular as Jaeger. They're also mostly controlled by companies. The only other one that's really open source in a foundation is Zipkin, which is not as active as Jaeger. It's a little bit older. Jaeger supports Zipkin instrumentation if you're using Zipkin. I don't really want to talk about company-owned projects because we don't know when the company decides to change the license. This is the whole reason why we created OpenSearch, is because Elastic changed a license on Elasticsearch. Although we still support Elasticsearch as a database in Jaeger, obviously OpenSearch is always going to be free. So yeah, and Sandeep asked a question, which is incidents where Jaeger saved the day. I mean, this tool is pretty indispensable for any company that's using tracing. I mean, when we go to KubeCon and talk to a lot of customers, it's everywhere from a big bank to, you know, a small startup that's using this stuff. There's lots of good commercial tools, but people also get started with the open source. They use the open source. It's still very popular. And it's a good way to get started with this and start to help out your team. Me personally, I mean, I've been part of some pretty big war rooms, you know, where we were using tracing, not necessarily Jaeger, but obviously in the US and now in Europe, Black Friday is always a big challenge for any e-commerce site, dealing with scales and bursting and trying to figure out the problems. Streaming sites, a lot of times when they have a live broadcast and they deal with huge spikes in volume, there's been a lot of interesting situations that I've been involved in helping diagnose problems with streaming systems. So I think anytime there's a big spike, the problem becomes a lot more visible when it's a, you know, really important event. But I think this helps, you know, every day when you can help diagnose customer problems, improve the user experience and the performance. So it's really valuable stuff. Cool. What else?
Right. And like, let's say there is always a SIG groups for Kubernetes to contribute on a specific like Kubernetes release. So do we also have similar SIG groups or similar Slack channels where people can
Yeah.
jump in and start contributing?
Yeah, so we obviously also have a Slack channel on the CNCF Slack. Always happy to have people jump in and help out. We have a monthly, actually I have a better slide in my KubeCon presentation. So we also have a monthly community call, and you can get the details on the Slack channel. And then obviously we also have a blog and an account on Twitter where we'll post kind of new things. We're in a monthly release cycle, so we release the project every month with updates. We just did a release a couple days ago, and obviously these are all in GitHub 4 days ago. So you can kind of see all the things that we're working on. We just did a pretty big release of version 2. We're still also supporting version 1. I don't want to, it's a big re-architecture project that we've been doing. So we're kind of moving on to the new version, which we announced during KubeCon US. That was kind of the first version of the first time we released version 2. And we've done a couple releases since then. So, yep.
Let's say when people want to start contributing, this is a regular doubt of every people that when people want to start contributing to any CNCF project, so
Yeah, for
how
sure.
they have question how which issues they should pick or how to get
Yeah.
started.
So the easiest ones are any open issue that has a tag of good first issue is
Mhm.
usually something that's pretty simple, easy to do. Some of them are, you know, minor documentation changes or things like that. So that's what we're always doing. We also are running regular mentorship programs. So we do Linux Foundation. We're actually just about to launch a new semester for mentorship. So the mentors help us out a lot on Jaeger. So that's a good program where you can get paid if you have time to contribute to the project. We also do Google Summer of Code. So that happens during the summertime where we get, you know, people that come and participate in those programs. So this is kind of the issue on the LFX mentorship term, which is going to be starting soon. And these are kind of the timelines associated with the mentorship and the details of the mentorship application process if people are interested. Yeah. So that's another way to contribute, and you can make some money, which is always good if you have the time to spend on the project. So.
Yep. So I think there is no more Q&A
Okay,
in the Q&A sections.
sure.
Tamis, Sandeep, if you have any questions. Okay.
Cool.
No questions. This was very helpful.
Yeah, Sandeep,
Sandeep wants to say.
we're very plugged in with the mentorship program. We've been using it for about 3 years now with LFX. So yeah, we're continuing to do it pretty regularly, and the mentorship's been really helpful. We got a lot of stuff done on version 2 through the mentorship, and yeah, it's been a really great program for the project. So we appreciate the contributions that Linux Foundation does to help us for sure. We all have full-time jobs and other work to do, so we do this, for the community and to build some great technology. So it's nice when people come and help out because everyone's busy, and I do think that it's important to spend time on these projects. So I hope you all get involved in open source, and I think you'll find it rewarding and you'll learn a lot and meet some great people. So definitely worthwhile.
Yep. Okay. Yeah. So I think that was really insightful regarding the project tour, first project tour with Jaeger. And so, what's your thought on this project tour? We just want to get a like what people think about this initiative.
Are you asking me that, or?
Yeah. Your overview about this CNCF project tours.
I mean, this project is popular. It's very stable. We were one of the first graduated projects of the CNCF. So, I think it's been good for the project, and it's nice to have stable technologies like Kubernetes and Prometheus that are all graduated as well to work with. So, hopefully that answers the question.
Like I was saying that, what's your thought on this CNCF project tour series or virtual series that we
Oh,
are
the tool
doing?
series. I think it's a good idea. I mean, one of the things that's nice that they do during KubeCon is we each have little booths, like a little pavilion, where we can talk about our project. Users can come and speak to us. And I think that that's a nice way where people can interact with the projects. They also do a tour of these where a guy comes around and brings a group of people to learn about new topics and new projects. So I like that you're doing that virtually, where you can introduce people to new projects and new areas that they don't know, because the landscape of CNCF projects is so big, no one can keep track of how many different projects and technologies, and they're super useful. So I like this idea. And I think there's, a lot of interesting projects for people to learn about.
Yeah. Okay. I think we are at the closing gate. Thank you, Jonah, for joining us and sharing your.
One
I think
thing,
Sandeep have one question.
yeah, so Jonah, I think I've put 2 questions in the chat. Maybe they are a little bit off topic.
I'm looking in the chat. Sorry. I
One,
don't see the question. Sorry.
okay, so my question was, how did you get involved with open source?
How did I get involved in open source in general? Before the Open Telemetry project started, I saw a trend where people used to use proprietary technology to do data collection for observability. And I saw a trend where, as the open source matured, that would be a big change in the industry. And I thought that it would be something that I'd like to be involved in, because I thought that there was a big transition happening, mostly because of open telemetry. And so that's how I got more interested in it. I'd always dabbled in it and used it. And, back in my early years, I was contributing to FreeBSD and other projects a little bit, but I got very interested in observability and open source, probably about 5 or 6 years ago, when I saw the OpenTelemetry project and other projects starting that I thought were really going to change the industry, and I wanted to be part of it. So that's kind of how I got a lot more involved in open source than just doing a few contributions here and there.
Yeah, just wonderful to hear that. So long back, before OpenSearch became like a full-fledged project, it was known as OpenDistro. It was in the very
Oh,
first
you're talking
stage.
about OpenSearch specifically. So I was involved because my company at the time was using Elasticsearch. And when the license changed, we were in a tricky situation along with lots of other companies. So with OpenSearch, we decided to fork the project and create something that everyone can use. Doesn't matter what you're doing with it. Everyone can use it. So that's why we created OpenSearch, and I was part of the initial team that started doing that work. AWS was very involved at the beginning. As you mentioned, before we forked Elasticsearch, OpenDistro used to just be a set of plugins and add-ons to basically enhance Elasticsearch. And after the license change, we made it into a full separate project, and now it's actually gone in a different direction than some of the Elastic stuff. But yeah, it's been a really good project and a huge amount of contribution, and now it's part of the Linux Foundation as of 3 or 4 months ago when we moved it over. So it's a very big project and a big undertaking, but it's nice to see it now part of Linux Foundation.
Congratulations.
Yeah, thanks. Took about a year, but we got it done.
Yeah, I think Dharmit has a question.
What's that? Sorry.
No, I don't have a question. I'm just very pleasantly surprised about the OpenBSD contribution. I think you said OpenBSD, or was it FreeBSD?
FreeBSD, but that was about 20 years ago. I did some work on that, maybe a little bit longer. So it was in my much younger days when I was in college and was doing a lot more work on FreeBSD early in my career, but I switched to Linux probably about 10 or 15 years ago. So yeah, I kind of stopped doing all the BSD stuff.
This session has been really very, very inspiring. Thanks so much, Jonah.
Thank
You
you.
had like a lot of nostalgia and inspired me a lot more to get back to coding contributions.
Yeah, I try. But yeah, thanks for having me on, and good luck with the rest of the podcast. I'll be tuning in.
Sure. I just want to ping a small hint for our next project tour. The next broadcast. There will be much more chaos. So you can pick the word chaos and guess the project.
For me?
Okay. Yeah,
Oh,
everyone.
Sure. Litmus, I'm assuming chaos. There's a few chaos testing tools out there.
You just hit a bullseye, but I didn't want to disclose it.
Well, you didn't tell anyone, so you're off the hook. I wouldn't worry about it.
Yeah, I will skip this part from the recording.
All right.
Okay.
Sounds good. Thank you.
Yeah, thanks, Jonah, for joining us and sharing your experience and knowledge with us for the Jaeger. And yep, that was all for the CNCF project tours for the first event. Thanks, everyone, for the joining.
Bye. Bye.
Thank you. Bye.